All right, hello everyone. Um, Thank you all for joining us today. My name is Michael Johnson. I am a postdoctoral research associate with the CS Everyone Center for Computer Science Education at the University of Florida. This is our logo. And in this presentation, I'm going to give you an overview of modality and materiality in regard to how it relates to reviewing and evaluating CS educational technologies to be used in a K-12 classroom. I'm going to talk about those terms, explain how they've been applied in a framework we're developing, and then briefly discuss some of the examples of the framework used in practice. And we'll have time for questions in the end. If you would like to follow along, the handouts I provided, Maya passed out, have all the information about the framework that I'll be going over. So in my past, I've both led and worked with other educators in designing CS learning environments, most often for K-12 students. And the more I've done that, the more I realize that there's just a lot of pieces you have to consider to provide the best experience. For example, there's the curriculum, materials, the classroom environment, and the students' needs. And while I'd love to discuss all of those, the one I want to focus today on is the choice of CS educational technologies students will interact with. Now, CS educational technology refers to a broad field of tools, which I will focus my analysis on, which is why I will focus my analysis on tools where the learner is responsible for programming a device and receiving output from it. And I call this group of tools programmable learning technologies, or PLTs. Now on the, oh, I forgot to just say, just on the right here is a picture of several students I've worked with who are exploring and evaluating PLTs as part of an activity that I will get to a bit later. Okay, so PLTs range from online code learning platforms to maker programs to tangible devices. And what makes the best PLTs are ones that can support a learner through formulating problems, expressing solutions, and evaluating their work without adding unnecessary complexity to the learning process. In general, when an educator selects a tool for students to use, such as a video, a game, crafting materials, a computer, or even just paper and pencil, they influence the outcomes of how students learn, retain, and are evaluated on computational principles. And how those influences occur is dependent on a tool's modality, how the user interacts with the tool, and materiality, or the material properties of the tool. So let's dive into those terms. The modality has come to mean multiple things over the past 2 decades, but I found we can best distinguish it into 3 forms. Coding modality, the means by which the learner writes code. Instruction modality, the means by which an instructional material is delivered to the learner. And feedback modality, or the medium through which the feedback or information is given to the learner, which is subject to the materials used. Now, these definitions all describe interactions, which is why I start them with the means by which, or the medium through which, the interaction happens. And while modality may define interactions with learners, it doesn't capture the various material properties of the objects in those interactions. And that is where materiality comes in. Now, the definition of materiality I've adopted for use in CS contexts is the properties associated with resources found in the learning environment and the implications of what they can bring to a learner's design process and development of computational thinking. A long one. Materiality is a bit more subjective than modality. It concerns both the material properties of the PLT, it's physical, it's virtual, etc., and what those properties afford the learner to create. And another way you can think about that is that it refers to opportunities to what a learner could make just as much as what they do make. Now, to better understand the differences between modality and materiality, let's look at an example. On the left, we have a screenshot of Scratch, and on the right are 2 students who are showing off their motion sound sensor activated lamp. The feedback modality of Scratch is the virtual application, which is running within the program. And the materiality includes how the program exists within a website, that it's a game, the setting that it takes place in, and so on. The feedback modality of the lamp is excuse me, that is like the tangible feedback loop of the light turning on when the sensors are triggered. And its materiality includes the physical materials making up the lamp, but also the fact that it is a lamp, that these students put their name on it and they colored it the way they did, all for specific reasons that connect to them in ways it wouldn't to others. And these terms comprise what we are simply calling the PLT framework. And since we now have a framework, we need to start testing it. So looking back at the question I asked earlier on, what CS educational technologies do we use, or more specifically, what PLTs do we use? We can use our framework to reflect on a tool's modality and materiality to understand what it might bring to the learning environment and how we might want to use it. What is promising about this approach is that if an educator knows what kind of CS learning environment they are working in or want to establish, we can match them with the right tool for the job. Now, looking back, let's see. Now, we want this framework to be something that teachers can apply, but we expect that they're going to need some more help in doing so than just like an explanation of the terms that I just gave you all. So we created a list of guiding prompts for them to reference. We started with some general questions, not getting into any specific properties, but rather asking simple things such as, what do you like or dislike about this tool? And what would be the benefits of using this tool with your students? Next were questions about modality, where we suggested teachers think critically about the interactions a learner makes with a PLT. And for example, that includes, like, we suggested that teachers think about how their students would write code with this tool and how instructions would be delivered to the students learning to use this tool, and how their students would receive feedback on whether or not the tool or an artifact they were working on was working as expected. And finally, materiality. As I mentioned earlier, materiality is more than just what a material is made of, but also how the material properties influence the learning environment. And so we challenge teachers to think of things like how the tangible and intangible properties of the tool might influence how a student learns with it, and the ease with which a student could make something personally meaningful. These guiding prompts form the backbone of an evaluation assignment that we had given to use in a pedagogy course at UF called the technology menu. And the technology menu was given to a STEM classroom management course this past spring for pre-service teachers. The course included both math and CS majors, so CS experience was not guaranteed. We gave the teachers a table with an abbreviated form of guiding prompts, which you can see on the backside of the handout. And we stylized the table as a menu where teachers played the role of a food critic, with the restaurant being the PLT that they were reviewing. And that was just for fun, but it did seem to make it a little more palatable for the teachers. The teachers reviewed a list of 7 tools. The assignment part. They reviewed a list of a set of 7 tools, 3 of which involved physical computing and 4 were online. And then they identified what one PLT they would most likely use in a hypothetical classroom and why. And to get more feedback on the framework's assistance in this evaluation, we asked them for their thoughts on using it. So of the 7 tools that we introduced to them, these 3 were the most selected for hypothetical use. The reasons the teachers were provided are summarized here, where they focus a lot on a PLT's ability to engage learners and capture their attention, teach different subjects at a variety of skill levels, and that it could provide instantaneous feedback. Regarding how helpful the framework was, there was a bit of confusion, like initial confusion among first learning the definitions, but teachers indicated that they did gain some clarity when they used the technology menu later on. Modality was often better understood than materiality, and most people, some people mentioned that aspects of feedback modality overlapped with materiality. But the general consensus about using the technology menu was that it was helpful and led to more detailed and thoughtful analyses of PLTs. So where does this leave us? The technology menu yielded promising results that we're still analyzing, and we are continuing to refine this framework. But I wanted to come here today to share this research with the Blockly community because I believe that this approach to evaluating PLTs allows us to critically think about how the technologies being introduced to the CS education community can best benefit the educators using them. And a better understanding of what properties PLTs teachers reflect on when integrating them into their classrooms has the potential to help developers and curriculum designers in making their products serve those teachers better. So thank you all for listening. I wanted to share that I couldn't have done this without the work and support of our center. Some of the those most involved with the research are shown here. And now I welcome your thoughts, feedback, and questions. Yeah.
One of the things we heard from not only teachers but also like administrators is when they're assessing like a new role or curriculum is like, does it align with standards by state? Is there a place where that sort of question belongs in this framework?
Yeah, I think that the where standards, well, how we might match a teacher or tell a teacher that something is being supported by their standards is like somewhere that it's adjacently related to what I'd like to do with this framework. What I'd like to do is I'm kind of working on developing like a database that will be of multiple different PLTs, and they'll be sorted, tagged by different properties, so teachers can kind of like look through that database and search for different PLTs by the properties they want. When they're looking at specific PLTs, I'd like there to be information about how it fits into standards. It's going to be, if they're making a website that's going to be like in general use, it might be a little hard to do one that is like per state specific, since some different standards go over different states. So we probably rely on like the CSTA standards to have those shown there, and then maybe a list of like state websites. Like we already know Florida has we use rely on the Florida's Department of Education standards for computer science classrooms already too. So yeah, that's where I kind of see it fitting in. Yes. Katie, go ahead.
Similar question around research. Do you ask teachers to think about any research that may exist on a tool, or does that come out naturally in discussion of these four categories?
I haven't asked teachers to think about any research on the tools. I maybe didn't give them enough credit to think that they had been looking at the research themselves, but they, I think my hope was that we were doing research for them and like providing them like findings in like the most up-to-date education literature. But I think that that's an easy question that could easily be asked.
One of the things on the website that you're developing is that there will be the research article.
Yes.
One of the tools themselves. So we're not relying on the teachers to do the research, but we're wanting to make sure that if there is research on the tools, that it's there. And so whatever is summarized within these modalities, summarized, but that the research studies are like there and linked.
Yes, for sure.
And my question was about cost. So all of these things that are equal in terms of what it will cost to work in your classroom and the physical things, there's obviously a much. Is that something you take into account? Because it obviously makes a significant difference to whether a student really take technology.
Yeah.
I'll pick the really expensive one.
I know, totally. Question about cost. I do wish we had more of the website now available to talk about it, because that's something that I want to put on it, like make that knowledge available to teachers ahead of time. My idea is saying that if they might find that they really like a certain PLT, and then once they actually learn how much it costs, they maybe did a bunch of research into it because they didn't know all of a sudden that it was cost. So like I want to be able to put that information out first, and then if they're like, okay, well that actually costs too much, within the modality materiality parts of like the benefits of this is that they might be able to look at that PLT and say, okay, well, can't use this one, so let me find something similar. Exactly. And they'll focus on the learning requirements for their environment and whatnot. We are at 12:16, so I don't want to keep people from lunch, but please feel free to come talk to me about your thoughts and everything. Thank you very much. You can keep your handouts, and if you don't want them, please just recycle them. That's all.